Hey everybody, Mr. Briz here, and what we're going to be doing is we're going to be getting into proofs of similar triangles, mostly focusing on the angle-angle postulate. Even though we've done proofs of congruent triangles in the past, I promise you I'm not going to require you to be as extensive with your proofs here. We're going to be a little bit more informal just because, well, since we're all learning this from home, I want to take it a little bit easier on all of you. So the first thing is just a reminder then of how to identify when figures are similar. So we need all sets of corresponding sides to have the same scale factor. You might remember this picture from before. The 2 and the 3 go together, the 4 and the 6 go together, the 5 and the 7.5, and then x and the 3 halves times x. And what is supposed to happen is this down here, where those ratios are all supposed to be identical. And then another thing too is that all of our angles, 85, 85, 123, 123, and so on, all of those angles happen to be congruent between the two shapes. Once we are able to show that, then we know that they are going to be similar. So one just quick note as well, all squares are always going to be similar. So the reason for that is, that's a very bad square, but since a square always has 4 right angles, and if I make another square, they all have the same angles, so that's one reason why. But then a second reason as well is since squares, all the sides are the same, if I happen to pick a number, say that this one is a square with side length 7, but clearly the scale factor is just 7 between those. 1 times 7 is 7. Those two squares have to be similar. Even if I change this to be 9, it doesn't matter. They're still similar. So the next part, circles are always going to be similar. Now, I know that circles don't have angles in them, but if we were to say, okay, this is a circle with radius, I'm just going to take it easy and say radius 1, and if this is a circle with a radius of 2, well, the radius is going to be the same no matter where we go in the circle, so that's going to be a scale factor 2 between those. And then just as a reminder, the word regular just happens to mean that all angles are congruent and then all sides are also congruent. So a regular polygon, for example, if I were to draw a hexagon, my drawing's not the greatest, but it's supposed to be just like a standard hexagon that you might imagine. Or another example would be if I try to draw an octagon, it's just your standard octagon shape. So that octagon there, and if I were to draw a regular octagon here as well, again, the drawing is poor, but the point is that they will always be similar. Okay, now that we've done that, we're going to get into the information that is necessary for our proofs. So the third angle theorem, this is going to be something that's going to lead into the postulate that I mentioned earlier. In a triangle, if we can show that we have two pairs of angles that are congruent to each other, that requires the third set of angles to be congruent as well. And an easy way to demonstrate this, now this would be considered an informal proof, but it'll work for us here. If I said that this is 30 degrees, if I happen to say that this was 60 degrees, well then that means that the other angle has to be 90. And if we do the same thing in the other triangle, well of course that means then that angle F has to be 90 as well. Now that we know that, that gets us into then a new way that we can, that says congruent, that's supposed to be similar. Proving similar triangles. So if we happen to have two angles of one triangle that are congruent to the two respective, I have a lot of mistakes going on here, I'm sorry. If two angles of one triangle are congruent to two angles of the other triangle, then the two triangles must be similar because of angle-angle similarity. Because we can then show the third pair of angles has to be similar as well, congruent. So in this case, for this first picture, we can show that triangle ABC is going to be similar to DEF. And in the second one, I can call this first triangle here MPN, and the second one will be RTS. And those must be similar. Just as a note as well, if we need to prove that triangles are similar, all 5 of these that we used before for congruent triangles can still be used then for similar triangles. We just need to show then that corresponding sides will have the same ratio. And I'll demonstrate that in a second. Now, one thing also that you should be aware of, even though we've listed angle side angle and angle angle side, those actually are not necessary to prove that triangles are similar, because they both end up just being the angle angle postulate anyway. So an example then would be if I decide to do angle angle side, and I'm just going to use the congruent mark even though we're doing similar shapes, so that's not really what we need. Well, it turns out this side was unnecessary because we already have angle angle right there. And then for angle side angle, same thing. I can just ignore that side right there, because without that, we still have 2 angles right next to each other, which means that the third one must be congruent as well. So that's why for angle angle side and angle side angle, you're actually going to probably never see those, because we'll just use angle angle instead. Okay, in this first example, we are going to demonstrate that triangle ABC is similar to triangle DEF. Now, we are not given any information about the angles, but we are given side lengths for both triangles. So we just need to match up what is corresponding. I'm going to go ahead and say, okay, 4 and 2 appear to be corresponding to each other, so I'm going to write that as a fraction. Then the next part is I'm going to use 3 and 6. And the last part, 8 and 4. And we see that all 3 of those fractions will simplify to become 2 over 1, or just 2. So since we have all 3 of them are going to be a scale factor of 2, that proves that these 2 triangles must be similar. And then our reason, well, we just showed with all 3 sides of each triangle that they have the same ratio, so this one is going to be similar because of side, side, side. All right, so this one I want you to try on your own. Go ahead and show that triangle ABC is similar to triangle DEF. Okay, now that you have done that, I'm going to demonstrate how we are supposed to solve this. So one thing that's going to help is that we already know that angle B and angle E are the same. So again, I'm not requiring you to do a formal 2-column proof. Instead, you can just write out what you know in these 2 triangles. So we've got angle B is congruent to angle E. Then we also are going to have 4 and 2, those right there. And then the corresponding sides down here, 8 and 4. Both of those simplify to become 2 over 1. And hopefully you could see then that these 2 triangles were similar because of, well, we've got an angle in between 2 sides. So therefore this would be side angle side. One thing I forgot to mention in the prior example too that would be useful here is that once you have shown that 2 triangles are similar, then the rest of the angles automatically must be congruent as well. So that may be something useful for you in the future. Say if you have to find a missing value in a triangle, you sometimes will want to show that it's similar first, and then that will give you a hint as to what the answer is for those angles. Okay, so I picked a little harder one here. This time we have a little bit more information too. We are told that DE is parallel to BC, so I'm going to write that in. And we're supposed to show that triangle ABC is similar to triangle ADE. Now, one thing that may be helpful for us too is if we separate these two triangles. So I'm going to go ahead and, oh, that's not drawn well. There we go. There's that one, and I'll label that ADE. And we know the bottom is parallel. And then the other triangle that we have, which is ABC. And we also know that the bottom is parallel. The reason I'm separating this is because I notice that both of these triangles share the same angle. Both of them have angle A up at the top. So we know that angle A in both triangles has to be congruent to itself. This is the first time now that we have used this for angles. It's still the reflexive property. So now that we know, this is an example then where we will use the reflexive property to show that an angle is congruent to itself. That is something that could show up then for trying to prove that two triangles are similar. Then the next part is that we can find another pair of angles that are congruent. I'm just going to choose those two right there. It's okay if you wanted to use D and B and the angles there instead, but I'm going to use these two, and we should use the proper names for them as well. So angle AED has to be congruent to ACB. Can you spot the reason why those two are going to be congruent? Hopefully what you've realized is that because we've got these two parallel sides there, those two angles are corresponding. And we know that corresponding angles are always going to be congruent to each other. So now what we have is an angle, we have two angles then in each triangle, there and there. And so we have enough information to show that the two triangles were similar. And the reason that they were similar is because of angle. Okay, so now I want you to try this one. Note that up at the top it was given that AC over CD is the same as BC over CE. And I want you to show then that these two triangles are congruent. Pause the video. When you are done, start it up again, and I will explain how to solve this. Alright, now that you have done that, let's go ahead and see how this was supposed to be done. So we notice that AC and CD are going to have the same ratio as BC over CE. So if that's the case, then it sure looks like we've got two of our sides taken care of. So what I'm going to do, just to kind of help us see this, this is not the exact values that we should be using, but I'm just going to mark it as 2x and x. And then for the other one, I'm going to mark it as y and 2y. Now, we have to go back to when we were doing congruent triangles in term 2. Here at point C, I spot that we've got two angles that are going to be congruent. And hopefully you remember that those are vertical. So we know already that we had AC over CD is equal to BC over CE. That part was given. We also know that angle ACB is going to be congruent to DCE. And we know that that's because they were vertical angles. And lastly, we can see that these two triangles were going to be similar because of side, angle, side. All right, so that covers everything. Your homework then is going to be the worksheet. Again, please look at Schoology. I will let you know which questions are required.